So in this lesson, we're going to be dealing with word problems involving exponential equations. So in this word problem, you have $100 initially, and each day that amount is going to increase by 5% of its previous value. So let's have a look at the numbers and what happens to the amount after certain days pass by. So on day 0, you have $100. But the next day, it's going to increase by 5%. So 5% of 100 is $5, and you add it on, so you have a total of 105. Now the next thing is, what happens to the second day? All right, well, it's also going to increase by 5%, and if you did all this work, you find 5% of 105, and then you add it on to 105, that would give you $110.25. So basically what's happening is there's actually a certain number that's always being multiplied from here to here, from here to here. And if you're to find the ratio back in grade 11, you take to find the ratio, you take the number and then divide it by the previous number, that gives you 1.05. You do the same thing for $110.25 divided by 105, you also get 1.05. So basically what's happening is that to get from 1 directly to the next number, you multiply by 1.05. So to get the equation to figure out the amount based on the number of days passed, what we're going to do is we take 1.05 is always being multiplied by a certain amount, and that certain amount is, let's call it x, the number of days passed, okay? And what happens is, what's your initial amount? Initial amount, you start from $100. And to make sure that this fits, all you have to do is test. For example, if you sub in 2 into the number of days, what is happening? Well, you're taking 100 times 1.05 2 times. So from here, 100 times 1.05 times 1.005, it's going to give you the $110.25. So I know this function fits. Once we have the function, we can solve for specific types of questions. And in this case, how long will it take for your $100 to quadruple? So what that means is, to quadruple $100, that would be $400. In other words, I want to have my final amount, or the set amount, to be 400. So, and we're going to be solving for how long it will take. In this case, it is x, the number of days. So we're going to sub this in. We have 400 is equals to 100, 1.05 to the power of x. We're going to be solving for x. So we're going to have to isolate for x, which is attached to the 1.05. This 100 is isolated from this bracket. We're going to divide everything by 100. That gives me 4 is equals to 1.05x. And this is where logarithmics come into place. There's many ways to solve for x. We can change this exponential form into a log form, where x is equals to log base of 1.05, argument 4, and then some students have a special calculator that can actually get the answer directly, or some students may have to change bases. So base of 10, because all calculators have a base of 10, and base of 10, 1.05. You can put this in your calculator, and that will give you the exact same answer. And you should get around 28-ish at the very end, 28 days. So here we have a similar question with the same starting amounts, but the thing is, this increases by 5% not every day, but every 4 days. So if we're to make a table of values, something is happening every 4 days. So instead of having 1, 2, 3, we're going to set it to 4 every 4 days, okay? Here we have $100. The next day would be the same thing as the same table as before, 1.05, or $105. Next would be 110.25. So the ratio is still the same, meaning it goes up by 1.05, 1.05. So our function is also going to be very similar to the previous one. We have $100, and we're going to multiply by 1.05 every 4 days. But it cannot be just x, because that's a similar modeling equation to the previous example, but something's happening every 4 days. Now before, it used to be 0, 1, 2, 3, but what's happening is that if the independent variable used to be 1, 2, 3, 4, previous example, but now it seems like it is stretched out, or I'll use the word horizontally stretched out. So what that means is, if we're to stretch out this model, this word problem, we're going to have to let the k value, which is the value beside x, to be over 4, 1 over 4. But to make sure that it works, all right, you just have to take one of these numbers, one of these set values, such as if you sub 8 into the system, into the function, you have 8 divided by 4, which becomes 2. In other words, you have 100 times 1.05 twice, which is exactly what's happening in this table of values. We can modify this question by changing certain values. So if I were to take this question, instead of having $100, make it 500, we know the first number before the bracket is going to be 500. If I change this to, let's say, something's happening every 7 days, then we know this denominator part of the function is going to be 7. If you notice this 5%, 5% is directly connected to 0.05. What I'm trying to say is right now is I change it to 25%, which is the same thing as 0.25. The base here would be 1.25. So in this question, it's a little bit different from the previous questions, is because what's happening is that things are going to be going down. So you have 5 milligrams of medication. So on day 0, today we have 5 milligrams. And then it says to clear the medication out of the system, your body, is going to reduce by 20% per day. So what that means is you're going to lose 20% or get rid of the medication in your body, 20% of the 5 milligrams. So every day what's happening is you're going to be losing 20%. So you need to calculate 20% of 5, and 5 times 0.20 is going to be 1. So you're going to lose 1 milligram, all right? But in this table here, it's the amount that's left over in your body. So we have 5, but we're losing 1, and we're left with 4. We do the same thing again. You find 20% of 4, which is 0.8. And this 0.8 is actually the amount that you lose. So to get the remaining amount, you take 5 minus 0.8, which is 3.2. Now, there is a more direct way to figure out the next answer in terms of the amount that's left over. So what I'm trying to say is if you lose 20%, that means you keep 80%. And if you want to figure out the ratio, right, you take 4 divided by 5, which gives you 0.8. You take 3.2 divided by 4, which gives you 0.8. So in other words, to go from here to get the answer directly without multiplying and subtracting, you take 5 times 0.8. So our function is going to be the following. The amount that's left over in the body starts off with 5, but each day it's going to go down. And if you notice this base value here, right over here, when you multiply 5 by a number that's less than 1, you're going to get a number smaller than 5. That tells me that the value is getting lower, things are going to be decreasing. And in terms of our independent variable, let's call it d for days. And because something is happening per day, we don't really need to put a fraction part. You can put d over 1, or you can just leave it like that. And of course, it's best to always check your numbers. So if you take 2 and you sub it into here, doing bed math, you should get 3.2. So let's actually, after finding the equation, we can actually answer some questions. So over here, let's figure out how long will it take, meaning you're solving for the d, for it to have 10% of the original amount. So 10% of 5, so 10% of 5 is 0.10 times 5, which is 0.5 milligrams. So this is the amount that you want to have remaining. So in other words, this is the A. So 0.5 is equals to 5, 0.8 to the power of d. So this is solving an exponential equation. We'll have to isolate for d using the inverse of an exponent, which is logs. So we divide it by 5, which gives me 0.1, 0.8d. And to solve for d, we can convert this into a log form, which becomes log base of 0.8, 0.1. For special calculators, it'll give you the answer directly. If you don't have a special calculator, you can change the base to base of 10, and you just put this in your calculator, and you should get some number, which is going to be around 10. So far we've seen two types of modeling questions. One is when something is increasing, and the other is when something is decreasing. So if you look at the format of equations, they look like the following. Y is equals to a b to the power of something. I'll call this a box. Where a is your initial amount, I'll put here starting amount. B is your, I'll call it the rate of change, how something is changing. And over here is the number of periods. For example, the number of days, the number of weeks, like what's happening every 3 days. So information about the time frame. And we know that if for the b, if you want something to grow, all right, meaning a is being multiplied by a number that's bigger than 1. So over here, the b is going to be greater than 1 in order for it to grow. However, if you want something to be a decay, meaning something is decreasing, you want the b to be less than 1. So let's have a look at a couple of equations and make up a word problem based on the following 4 questions. So between these 4 equations, you got 2 of them that are increasing and 2 of them that are decay. And you can see this by looking at the base. This is 1.4, meaning 50 is multiplied by 1.4. You're going to get a number that's bigger than 50, meaning things are going to be growing. This one here, there's no number in front, or there's no number, it's a 1, but 1 times 3 means, oh, it's going to triple. Things are being tripled. This one here, you have 1,000 times 0.89. If I take 1,000 times 0.89, I end up getting 890, which is less than 1,000 that what I started off with. So I know that things are going to go down. Here, if you multiply these two numbers, you know that this 8 becomes a number that's going to be smaller than 8. So these two are decreasing, decay. These two are growth. So let's make up a word problem. So let's look at the first one here. I can say that, oh, maybe you have $50 and every 7 days, or you can say every week, where 7 is the number of days, something is going to increase. Maybe your $50 is going to increase by what percentage? Well, 0.4 is the same thing as decimal form for 40%. This one over here, you can say, oh, you start off with one bacteria, and it's going to triple every 5 months. This one over here, you start off with $1,000, but what's going to happen here? Well, it seems like your $1,000 is going to go down by a certain amount. Is it going to go down by 89% or go down by 100 minus 89, which is 11%? So which one is it going to be? So when we talk about decay, we're going to have to look at not what we keep. This 0.89 is the amount percentage that we keep, but it doesn't tell you how much we lose. You have to subtract that from 100. So in this case, this problem is you have $1,000 and you're going to lose, or your money's going to go down every day by 11%. Okay. This one here, you can say you have 8 grams of something and it's going to go down by how much? It's not going to go down by 0.045%. Now 0.045 is a decimal form. If you want to change it to a percent, you just multiply by 100. That becomes 4.5%. What this means is you keep 4.5% of the 8. Okay. So you want to figure out the decay rate, how much you are losing. Okay. In this case, if we're keeping 4.5%, that means the situation is you're going to be losing 4.5. Sorry. You keep 4.5%, but you're going to subtract these two to get 95.5. This is the amount that the percent of loss. So in the 0.25, so if you look at this point here, it's not in the usual fraction that we're used to, but if you change it to a fraction, 0.25 is the same thing as 1 over 4t. So going back to this question here, you have 8 grams of something, and you're going to lose 95.5% of it every 4 days. So sometimes you might have a decimal that may not make sense, but you can change it into a fraction where you can see what's happening every nth number of days or weeks.